Louder, please.
Myself, Priya. So we are going to be discussing about alternating current. The first topic is RLC series with AC circuit. So I will be explaining about circuit diagram. I will be explaining about the phasor diagram.
Okay.
So
as far as this RLC series with alternating current, both are important. You have to include both. Whenever you write this question, okay, you have to include both circuit diagram and the phasor. Okay, right. Proceed with the circuit diagram.
Priya, what is the RLC?
Now you can mark it so that everybody can watch it clearly.
R represents resistor, L represents inductor, and C represents capacitor. Okay. What is this symbol exactly? So this circuit is connected to an AC source, which is nothing but an input. It is like an input. Can I know what is that I and V are what direction? Yeah, it only represents the direction. We both are going in the same direction. Why do we have to represent this? Yeah, voltage across an inductor leads the current by 90 degrees. So we are representing it as this. Voltage across a capacitor lags behind the current by 90 degrees. So we are representing it as nothing but pi by 2 AV. Yes, pi equals to pi. Why do we have to represent all in the subscript of V? Which is nothing but the voltage across an inductor, VR means resistor. Voltage across an inductor, VL means VC means voltage across a capacitor. That's all.
And can you explain this phasor diagram?
Can I know what is this phasor? So phasor, first it origins from the phase angle phi, and phase R vectors.
You can make use of this notes also,
okay,
where we have explained about the phase relationship.
Okay, phase relationship between voltage and I, that is the two vectors. So phase plus vector, that is phasor. That is the name phasor diagram. And the next point, phasor means a vector rotating about the origin with the angular speed omega. Magnitude of the phasor is equal to amplitude. Amplitude is nothing but the peak value. When a wave goes in a height or amplitude, it attains its peak value. That is a peak value of quantity that can be either voltage or current. That is phasor. So can you explain about this part, VL minus VC? Sir, in this part, VL is moving upwards and VC is moving downwards.
What is VL?
VL is nothing but voltage of an inductor, and VC is voltage
Across the plates of the capacitor.
Plates of the capacitor. Why we are taking VL minus VC is to show the difference between VL and VC.
Now actually being a vector, the VL is going upward and VC is going downward. So the net will be what? VL minus VC.
VL That's is the larger value, so we should minus VC.
And what is that phi?
Phi is nothing but it is used to indicate the angle between two vectors.
That is the phase angle. Phase or angle. Or phase of the rotating vector. Okay. So which are the two rotating vector here?
Sir, it is V.
Current vector.
Current vector and voltage vector.
Good. Okay. Now you can proceed this.
So the first one is power factor. Cos phi is also known as the power factor, and the average power loss over complete cycle is P is equal to V into I into cos phi. And next one is the wattless current. Wattless current is nothing but when in a circuit power is zero. Power's unit
Why
is watt.
it becomes zero?
It becomes zero. Cos phi 90 degrees.
Because cos phi is equal to 0. Why cos phi is 0?
So cos 90 degrees.
So phi is equal to 90 degree, that is pi by 2. Therefore cos pi by 2 is equal to 0. And that is why?
It is powerless.
Powerless current. It means wattless current. Why it is called wattless current? Because
so no power is dissipated.
No,
even though
I do agree with you that power is the, watt is the unit of power.
Yes.
And that is why when there is no power means no watt.
No watt.
So wattless or powerless. Okay, right.
I already told what is a phase now. And
You can explain about the phasor, just to give the definition also.
Phasor relationship between voltage and current represented by phasor. Phase relationship. Phasor is a vector rotating about the origin with the angular speed. Here vector can be voltage or current. Magnitude of a phasor is equal to the amplitude. Amplitude is nothing but the height. And peak
Wave height, you can call it
height.
wave height.
And the wave height is nothing but the peak value. When it's at the maximum height, it is at the peak. So the
It can be on the negative side also.
yes.
That is the deep valley. So in terms of crust and trough, we call it crust as the top one, the maximum. Down, the lowest, lowermost position is trough. That is the negative amplitude. So, but we don't call it positive, negative. We take the modulus of this height, and that is why it's called amplitude. In fact, this is square of the amplitude that indicates the intensity also. Okay, right.
And the next one is the most interesting characteristic of RLC series is the phenomenon of resonance. Amplitude of current is maximum at the resonant frequency. So when the circuit exhibits resonance, the amplitude of current is at the maximum at the resonant frequency, that is nothing but omega naught. Omega naught is the angular resonant frequency, is equal to 1 by the whole root of LC, which we reciprocate, and Q is the quality factor, the important aspect, is equal to omega naught into L by whole divided by R is equal to 1 by omega naught CR.
Great, very good. Any doubt? Okay, good, very good. Thank you.